our Zoom and share. Thank you. All right. So I'm going to create this. And now I've got my information here in my GitHub repo. This is all it has. So it's kind of a folder. It's not completely empty. Right now it has a git ignore file, which is the one that says ignore these Unity log files because they can be huge and we don't need to update them every time they change. Has my license file. If you looked at that, if you clicked on it, you should be able to see what that brought in about general use of your software and all that great licensing stuff. Now I want to go back to that main folder, so I'll click on my repository name again, and I see my README. Now my readme.md is showing up here as a file, and right below that, it's displaying the contents of that file. That's because MD stands for Markdown, and a Markdown file in GitHub is a file that contains information that can be displayed. So let's edit our readme.md. Right now, all that file has in it is one line. The line starts with a pound sign, and in the world of Markdown control code, a pound sign says, display this line is a header. So that's fine. I'm going to add another line or two. I'll just create a secondary header with 2 pound signs and put my name. And then maybe I'll put Ozarks Technical Community College. And I'll commit these changes. And I'm just going to not worry about anything else that's on that screen because I just want to commit them back to that same spot. Now when I look at my repo, my readme.md, my markdown file is displaying that new information. So anybody who comes along and looks at my repository is going to see that markdown file, so they'll see that little bit of information. From the Unity repos, I actually have gotten comments and remarks from GitHub from other users. Don't usually get those very often from, you know, intro to Java code, but for Unity code I do. People will ask questions and things, so that's cool. Okay, so I'm going to now leave my GitHub repo, but before I do so, I want to set myself up to clone it. So I'm going to copy my clone information. Now we have a really cool tool, not we, but the world does, called GetCrackin. Let's go download it. So it is a Git utility, and it's from a third party, from somebody else, but it's free, and so it's kind of handy. We'll use it. Let's go ahead and download it. You should be able to install it on these computers. It installs into the users folder, so it doesn't make any updates that require security access to the computer. So go ahead and download it and install it. It does take it a second, I know. You'll see why GetCrackin too after we use it a little bit. It's kind of handy. All right, mine's already installed, so I'm going to open it. Now, a GitHub repository is cloud-based storage, and it's keeping all of our source code out on the web in the cloud. But if we want to use our code, we have to copy it to our local machine or pull it to our local machine. We have all sorts of messages there on that thing, huh? Yes, sir?
Should we sign in with our GitHub account?
Yes, do sign in with your GitHub account. Thank you. Now, mine has a few things. But if you click on your file menu, or actually just on this little file folder right under it, that's kind of where I want you. It'll bring up this repository management window. And what we want to do first is, I think that we want to I'm going to say clone. You guys can shoot me if I get something wrong. Is it right? Because every time I do it for brand new, I'm like, oh, wait. Now, what I want to do is clone that repo that we created out in the cloud down to my local machine. From then on, once I clone it, I want to keep the two in sync. So I'll issue some different commands to make them stay in sync. But to get started, I want to do a clone. Now, before I can clone, I'm going to tell GetCrackin the URL on GitHub is that one that I just copied, my CIS220. But I want to create a clone location on this local machine. So where to clone to. So I want to click Browse and decide where I want to clone this. Now this means, where do I want to work on these projects on my local machine after I've gotten them pulled down from GitHub? I want to create my local repository on my external. I have an external hard drive that I usually take with me, so I'll clone it to that. In my external, I'm going to go to my CIS220 folder. And I'm going to create a new folder for SP19. Now notice that GitHub wants, or GetCrackin wants me to select a folder, not a file. So I'm going to select that SP19 folder. I want that folder to be the place where I connect to my GitHub cloud-based storage. So I'm going to select it. So now I've said, this is my local repository. This is my GitHub repository. I'm ready to clone. Now up at the top, I'm going to click Open Now. What the heck? Clean up some of that mess so you guys don't see it so bad. So now this is what my repository looks like in GetCrackin. All it's really showing me is that folder that I just created, my CIS220 folder. So I don't really have anything in it. So I could do some things to try checking in to GitHub. In File Explorer, I remember last time we created that Hello World project. I would like to put it in GitHub. So to do so, I'm going to copy it or move it to that folder I just created, my local repository. From now on, I'll just create my projects in that local repository and I won't have to move them. But this first one I didn't, so I need to move it. So I'm going to go find it. I remember I saved it on my external also. And I had to create this Hello World V2 in class. That's the one I want. So I'm going to copy it or cut it, whichever you prefer. And then I'm going to paste it into that new folder that I just created that is my GitHub stuff. Now, when you go into that folder, notice, got your repo. Now, I have to go into the CIS220 SP19 folder. And now I see that .git folder. Do you see these hidden things? If you go to your view menu and you make sure you're showing hidden items, you should see all these hidden Git files. So when you see those, then you know, oh, this is a Git repository because it has all these hidden Git files in it. That's the one I want to paste this project folder into. And we're just going to do this one because it was our small Hello World project, so it's not nearly as huge as they'll get.
Now there's probably some way I could have pasted this and done this in GetCrackin, but I am not 100% sure about that. But now that I pasted it into my Git folder, if I go back to GetCrackin and maybe click on this item, view all files. Where is it? It's not showing it. Ah, that's what we want. View changes. Thank you, sir. And now we should see all of those project folder content files that we just copied. Whenever we use GetCrackin, it uses a terminology that starts out with staged, all changes. Now all my changes are staged. They're ready to be copied up to GitHub. To copy them to GitHub, I need to put in a message down here in this commit message area. So some sort of helpful message to me to let me know what this commit was. So I'll say this was the initial commit of Hello World. And as soon as I start typing in a message, my button becomes available. And it says, would you really like to commit all of these changes to GitHub? Yep, I'm going to click it. I would. So now according to GetCrackin, they're all sitting here. It says they're all added. Do we need to do anything else? We have to push them. I'm going to bring up my GitHub repository here to show you maybe. So in my repository right now, I still just have that GitHub, gitignore, my license file, and my README. So now I'm going to push all of this stuff that I've committed. It says pushed successfully. So now if I go to GitHub and refresh, oh yay, I have my Hello World project. Now because I copied that whole project folder into the GitHub folder, I have my whole Hello World project folder here. Now when I get home, I can pull all of this stuff or clone it. So the first time I'm just going to clone it to my home computer. That's going to copy down everything that's in this GitHub repository to my home computer. From then on, I can just fetch things, and that'll give me all of my updated files. Fetch, 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 push, updates. So today, when we work on our project, remind me we want to push those changes to GitHub before we go. Yes, sir?
What's the difference between pull and fetch?
Pull implies a lot, like that you're going to update those files, that you have an update intent. And fetch just means grab them and pull the most recent version to my computer. So fetch is kind of like, I just want to be able to run this project. Pull is like implying that you may update the project. So either way, depending on what you're going to do. So I'll do fetches on you guys' stuff so that I don't accidentally like lock something so that you can't do your updates. But when you pull it out, you'll probably want to do a pull. So I'll say fetch, but that's just me. Okay, so now we have this GitHub repo set. I could clone this thing at home and have my whole Hello World project there available for me to work with. So I want to use that folder now because that's where I'm going to create my new projects. I'm going to minimize GetCrackin and GitHub and go to Unity. Our guys in the back are working hard on getting stuff ready for you guys to present about the terrain editor. And some of you I know have already created this project. So again, you're welcome to just follow along with us and offer insight and help.
or do what you want to continue on. Now I'm looking at the online version of the textbook, and I'm going to be looking at this section 3, chapter 28, our apple picker prototype. So that's where I'm going to be starting at. And as we make our apple picker, we're going to remember that we're doing a prototype. So we're not doing a full-fledged game project here. We're going to be using temporary graphics. So they're not going to look as beautiful as good graphics. So whenever we put our graphic elements in, try to do that, you know, just put in these prototype things. Then you could come back later and work on it and make it much prettier. But don't get all sidetracked making your tree look beautiful unless you're going to pick it up on your own later. So this should be more fun for us that way. So we want to name this project Apple Picker Prototype, and we're going to start out with our scene 0. We're going to have some different scripts here by the time we get done. We'll have at least 4. So we're going to be creating them right off the bat so that they're already out there, but we're not going to attach them to anything to start. So first I want to create my project. I'm going to use File Explorer, and in my new GitHub repo folder, I'm going to create a new project folder. And I want this to be Apple Picker Prototype. Oh, thank you, sir.
If you just make the project, it makes the folder automatically.
Right, and I want the project folder inside this folder. So I want it 2 layers so that if we have a point where we want to copy that whole project, like a point in time where we want to make a duplicate so we can try some things, we'll have an outer folder still to hold it all. And that's what our textbook recommends. So we'll just do that, and we'll go ahead and create it as a new project. Now again, I want it to be the Apple Picker Prototype. And my location, I need to change. Make sure again that I'm in my GitHub repo where I just created that new project folder. Keep going, here it is. So inside my Apple Picker Prototype, and that's where I want. So I always go down 1 layer too far. You guys probably don't do that. But I'm going to stop at my GitHub repo, 220 SP19, select my Apple Picker Prototype folder, and then choose Select Folder. And then we will get that new folder created within that one. So yes, we can get some pretty deep folders. But we'll be safe that way. So let's go ahead and click Create Project. It's being slowpoke. I like it because it gives us lots of chance to visit while it's creating new projects. We used to always kid at work, installing new software and stuff is great because it gives you a chance to visit with everybody else you work with. Otherwise, you're always too busy. Now, because again, we can't install any updates, we'll be continuously skipping new version. I'm going to uncheck this checkbox to check for updates because I can't install them anyways, and then skip this new version. So hopefully it'll quit bothering me about that. Someday maybe we'll be able to use virtual machines or something, and then we can get everything perfect exactly the way we want it. That would be great.
Of course, IT would only IT would have the authority to install the virtual machine.
Yeah, but if we could, that's true, they'd still be a backlog. We'll see. We'll see. Have you guys seen Docker? Docker's going to be the solution. Docker's going to get us there someday. With Docker, you can just set up a few commands and say, I want to create this environment, and just create it. But the IT guys will have to figure out a way to control it, or we won't be able to use it, which is right. They've got to worry about it. So we've got our little project created here. Everybody's all created. I've lost something. I don't know why. So we want to go ahead and create our first scene. So let's do File, Save Scene As, and we want to name it _ scene _ 0. Let's go ahead and put it in our scenes folder. _ scene _ 0. And save. Now, down at the bottom of my screen right now, looking at the default view, I'm seeing the console window. I want to switch to the project window. I could actually go into my scenes folder and delete that sample scene if I wanted to, if it was bothering me. It's not bothering me, I'll leave it there, but if you want to get rid of it, do so. I also, over on this side of the window, I'm seeing this Apple Picker stuff, also all these cloud services, which I don't want to see, so I'm going to click on my inspector window instead. Now, if you like the layout of this window, that's great, but if you'd like to change things around, you can. So we didn't really get a chance to look at that last time. Let's do it now. Right now, my game and my scene windows are separate. Last time when we brought things up, they were overlaid. I'm going to drag my game and scene windows together. Come on, you silly thing. Try to put that tab beside that other so that now they're side-by-side tabs instead of taking up all that space on my window or on my display. Now, whenever we're working with these different windows like that, every tab is a different window. We can grab a tab and drag it and drop it someplace to change its location. Get it the way we want it. Now, in Unity, there might be other changes that you might like to make. You might want your hierarchy screen over on this side, or maybe you want it down on the bottom. Some people like their project up here and their hierarchy down at the bottom. All those different things are possible, however you want to set it up. Once you get it the way you want it, you want to use this layout option up at the top of the screen. You see it up here? And save that layout. So if you've got it all the way you like it, save that, because you could easily get things messed up. Now, if you have it the way you like it, once you save that layout, it's going to show up here in this list of saved options. Try some of those default layouts. The 2x3. See how that looks? There's the 4 split. Now, what's the 4 split showing you? All of your different perspectives of your design window. So you're going to have, you know, from the top, from the bottom, from the side, all those different perspectives. We can go back to the default view. We could try tall. I kind of like that one. That's one that I kind of was used to when I first started using Unity. Different developers like different ones, and they show you how to use them, and that's what you get used to. Or wide. This is a really common layout that a lot of people like. So no matter what, you can try some different layouts. If you get it all messed up where you can't find a window, you don't know where it's gone, you can revert back to the factory settings. I'm going to go back to default so that you guys can see where things are on my screen. Depending on how you like it, you might want to change it a little bit. Now, we want to go ahead and create these C# scripts. So let's do that down in our assets. We want to create C# script. The first one is going to be named apple picker. And then we're going to create another one. This one will be apple. One more. Apple tree. And finally, basket. Now remember, if you were to copy one of these, instead of creating a new one, the class name inside that C# script would be wrong, right? It would be whatever you named the one you copied from. So until you get really comfortable with that C# code, make sure you create each script individually on its own so that Unity can put that heading information in the correct format to match what you've said you're going to have. Now, we've got our scripts. We're not going to attach them to anything right now, but we will here in a minute. It is just like C#, it's using C#. So let's create our artwork. Do you want to save all first? I do. I'm going to save my scene, and I'm going to save my project because I have all these little things. Now, I want to do my art assets. Whenever you're looking at moving your windows around and things, this is great if you have dual monitors or quad monitors. That's what we all need anymore, right? Quads. Because then you could move your game design window to one monitor, and you could have your play window on another monitor, and maybe your inspector window on one, and Visual Studio where you're editing your C# code on that fourth one. We all need 4, don't we? I think 4 is just the right number. So don't forget that you can do that with dragging these tools around. You can put them on separate monitors so that you're the ultimate developer. So the first thing we want to do is create our tree trunk. So we're going to use a cylinder. So we want to create a new game object. It's going to be a 3D object, and it's going to be a cylinder. When we look at creating things here for our prototype games, we're going to be setting all of our positions, our transform characteristics manually. So we won't be doing a lot of dragging and dropping around on the screen or resizing using the controls. But you could do that. So don't forget, you know, just because we're going to be going at it programmatically, you can still use all those visual tools to resize things and move things around. But in order to make sure that we get everything in the right place and we don't lose a lot of time finding things, we're going to set our transforms manually. So for our cylinder, we want, first of all, to come over to our hierarchy screen and rename it to be trunk. Is there a place that you could rename that on your inspector screen? Yep, right up here at the top, if you see that. And notice up at the top too, what happens if you uncheck that checkbox? It disappears. So it still has a placeholder in our scene, but it's not visible. So be careful of that, because if you accidentally check that or uncheck that, it will disappear from your scene. Now we've got all our transform set, all our position, XYZ properties are 0, our rotation properties are all 0, and our scale properties are all 1. So let's see, that's our ugly cylinder. That's all they're saying to do right now. We'll probably be coming back to it to fix its color. But for right now, let's add a sphere, which is going to be our leaves. So again, we want to create a game object, 3D, sphere, and this one we want to call leaves. This is going to be kind of the top of our tree. So for our leaves, we want to change our position a little bit. So our Y coordinate, we're going to make 0.5. And then our scale, we're going to make it 3, 2, and 3. Should look a little bit more like the round top of a tree if you need glasses really bad. So just showing us that way. Okay, so there's our tree so far. We've named it leaves. Now, the leaves and the trunk together should look a little bit like a tree, but they're separate objects. So let's create an empty game object to act as their parent so that we can encapsulate the two of them together under a single object. So under our game object menu, you should find create empty. And that's what we want to do. So we've got this game object here now that's just an empty game object. We want its transform position to be 000000111. So make sure that position is set properly. Now our game object, if you notice, this empty game object only has the transform property, its position, so it's super handy for being a container. Let's change its name to apple tree. And then for our apple tree, let's drag our trunk and leaves into our tree. I drug my leaves, but they just went below the tree and not into it. So you should see your trunk and leaves indented under that apple tree game object. And now we know that's a group.
How do you make it?
Just over here, create your empty game object and name it apple tree, and then just drag and drop those things into it. Simple. Now you can try some of your different hierarchy views. Let's try that. Instead of looking at our default layout, what if we try that 4 split? Remember, it showed all those different orientations. So notice then, here we're looking down at the top of our tree. We have, you know, our left view, our right view, all of our different orientations. I'm going to go back to default. Just want to remind you, we can see all of those different ones. So our apple tree is looking a little bit sort of-ish like a tree, maybe a water tower, I don't know, something like that. Now, if you look at Unity's title bar up at the very top, do you see that little star? Is that telling you you have unsaved changes? He says it is in the book. Let's save our scene. Oops, I didn't mean save scene as, I meant save scene. And then as soon as I do that, notice that asterisk is gone. So that is warning us that we have unsaved changes. Now the tree is building, it's looking good. If we resize, if we move, scale, or rotate our apple tree, both the trunk and the leaves will move and rotate alongside it. So let's try it. In your apple tree, make sure that you have your apple tree selected in your hierarchy. I got to select the whole thing because right now I was just looking at one part of it. And try changing your scale. Let's just try going 2, 2, 2. And so notice that's changing the scale of both of those components of that tree. I made it twice as large as it was. Now we could try other things too if we wanted to. Right now I have the rotate tool selected, so I could click on any of these rotate things and move and make a big mess, right? So don't forget to Control Z. Things get wacky. So some of the tools, you know, when you have grouped things are going to be a little bit different than how they would behave if it was just one object. All right, we want our apple tree to have mass. We want it to be a rigid body. So I want to select my whole apple tree. And on my apple tree, in the inspector, I want to add a component. We want to add a physics component. And what we want to add is a rigid body. Do you see that rigid body component? Now, do you remember what did the rigid body give to us?
Gravity.
Gravity. That's a really important thing. So here it is, we are saying yes. And so it kind of gives us mass, right? It's all of the aspects of gravity because it's like how huge of a mass do we have? How much drag is there against it? Is there angular drag or is it just straightforward drag? So we have some different characteristics that all are related to the gravity. So we want this thing to just be something that is involved in mass. We're going to make it something that the apples fall out of. So we don't really want it to drop down out of space. So we're going to uncheck the use gravity. We don't want our tree to fall down. Well, the reason that we wanted to add this rigid body component is so that the colliders of the trunk and the sphere are updated when we move our apple tree across the stage. So it's going to be moving around and we want to make sure that it's working right. We could play if we wanted to. Look at our water tower. It doesn't look like an apple tree to me yet. So let's make it look like an apple tree. Let's add some materials because right now it's just looking like a water tower. So let's go to our assets menu and create a material. Now we use a material anytime we want to add color or any other sort of physical attribute to an item, reflection, all those kinds of things. This very first material that we're going to create, if you notice, goes down into our assets window, and we want to name it in a way that is meaningful to us, that it's a material. So we're going to prefix it with MAT underscore. And the first material we want to create is our wood material. Now in your project pane, when you have your wood material selected, you should see it showing up in the inspector. So right now it's showing some things about this material, but it really still looks just like the other stuff, right? So nothing good. So we want to come up here to this albedo color and click the dropper. Sorry, click the color screen itself. And this should bring up the palette. Find a nice brown that you like. That looks good. So notice as you're working with the color picker that your material should be getting updated. And then you can just close the color picker when you get it the way you want it. I've got a brown, kind of a light brown. You might like a darker brown, it's up to you. Now you can also, once you've got your color picked, adjust some other things. So right now, my material doesn't have any sort of metallic capability. I think I'll wait and I'll add that to my apples. I like the apples to look all real shiny. Now we can do any of these other settings if you want to try. Reflections, is it glossy? Turn off reflections and see how it looks kind of matte. You can see what happens there. So in general, you're going to want to leave your specular highlights and your reflections turned on, but sometimes you might want some sort of something that's more matte like that, that blends in. So however you want it. Now this is our wood material. So we want our wood material to be on our trunk. So just like all the other things in Unity, we can just drag it and drop it on our trunk. And now our trunk is using that material. Isn't that cool? So it's super cool because you can also, you know, get in images and patterns and things like that if you want. We're just doing basic colors. So let's create another material then for our leaves. I want this material to be named MAT underscore leaves. And for the leaves material, again, for my color, I think I'm going to find a green. I kind of like that really bright green. You might not want such a bright green. It's up to you. You could adjust all of these different aspects of your color. I like that material. I don't want it to be metallic or anything like that. I'll just take that leaves material and drag it onto my leaves. And now it looks a little bit more like an apple tree. Now again, when you play with the material editor, you can do so many things. Don't lose all of your time of your life there. But it does give you a lot of really cool capabilities. Let's run your game again. Let's play it. And our tree should look a lot better than it was before. Oh, happy. I'm happy with my tree. It's looking pretty good. Much better than that pitiful tree I had earlier. I'm going to stop, run. And again, I think I'll go ahead and save. Being not an artist. Now that we have our apple tree made beautifully, it's just the way we like it, let's drag it from our hierarchy screen to our project screen. And if you remember, that makes that apple tree into like a template, right? Makes it a prefab. Now that we've made the apple tree into a prefab, in some instances, we're going to want to leave an instance of the apple tree over here in our hierarchy window, but generally, we don't need to. I can't tell if they want us to delete it or not. Let me check. This stupid thing keeps giving me messages, and it's overlaying what I'm trying to do. They don't say anything about deleting the apple tree from our hierarchy, so I'm going to leave it there for right now and see what they want us to do with it here in a minute. So we'll leave it there. But we want to look at our light. So all of our Unity scenes, we saw this last time, come with that directional light already included. Whenever we set up our directional light, we can modify some of its characteristics to make it work for us. For this very first light, we're just going to change some of its transform properties. So we want its position to be 0, 20, 0. We want its rotation to be 50, -30, 0, which is very close to what it is, at least in mine. And its scale to be 1, 1, 1. So if you notice, it didn't really change a lot, just kind of our y-axis. Run your game again and see if you can even tell any difference in how that camera is looking at your tree. A little bit, but not much, right? Pretty much the same. Okay, but that gives us a nice diagonal light across the scene. The position of our directional light is unimportant because directional lights shine in the same direction regardless of the position. But we've given it a position of 0, 20, 0 to move it out of the middle of the scene, because its gizmo, or its icon, would be in the middle of the scene pane otherwise. It's kind of in our way. So you can just move it out of the way if you like to. Now we can move our apple tree up and out of the way a little bit by changing its position. So if we want to get it out of our way, let's take our apple tree and move its Y position to 10. And now it's kind of out of our scene. But we could use our control, whoops, no, or just our, where am I? Yeah, Alt. Yeah, I wanted to move up in my scene, but scrolling in and out will work too.
Hold the middle mouse to translate across the screen.
Ways, ways, ways. You got it. All right. So we want it out of the way anyway, so we're okay. We can zoom in and out using your wheel, all those different things. Try them. So many different tools. Now let's make an apple. For our apple, we don't care exactly about the apple tree right now. We just want to create our apple so that we can create a prefab. So we got that tree out of our way so we can work on our beautiful apple. So we're going to start with a sphere. Let's create our 3D object sphere. Now our transform positions are a little wacky. I need to fix mine. I want it to be 0, 0, 0. and then 000111. We kind of use that as a standard. Now let's create a material for our apple. So I'll come down here and create a new material. And let's name this MAT_apple. And for our apple material, we want a nice red. Now I kind of want mine to be, like I said, super shiny. So I'm going to take my material and I'm going to add like a metallic kind of glow to it. Now you see some advanced options here that have to do with whether you want your graphics card to maintain this instance or your processor. So those would be really advanced options. Lots of things you can do with materials because rendering materials is what takes a lot of horsepower, right? Okay, well our apple color looks good. So I'm going to put that onto my sphere. And I'm going to rename it Apple. And then I want to add some physics to the apples because I do want them to drop. So make sure you're clicked on your apple and looking at your inspector, add that component. We'll add our physics. Rigid body. And then in our rigid body, we shouldn't need any other settings. You can go ahead and run and make sure the apple drops. Yep. Cool, so our apple is dropping the way we want. Now, whenever we're working with components in Unity, sometimes in our code, we have so many different components going that we need to know something about this component. And we can use this tag property to tag our different components as types. So we want to do that with our apple. So up here where this tag is, let's add a tag. So when you click on that, you should be able to see add tag. So we're going to add a new tag.
My apple isn't visible.
Uh-oh. Did you fix it?
You uncheck it.
Yeah, if you unchecked that checkbox by its name, it'll be inactive.
How do I get out of the tag?
How do you what?
Get out of the tag menu?
Just click somewhere else.
It's not.
Now we want to create an apple tag. So do you guys see it? Do we need to put them on the screen? Do you see the problem? Thank you, John. Okay.
Thank you.
Yay. All right, so we are going to create this apple tag. Now, we know that this is an apple, but when we're working with components in our code, we want to make sure that the object type we're looking at is an apple. So now I should be able to click back on my apple to look at all of its information in the inspector. Instead of saying untagged, I want to tag it as an apple. Did you get it? That one is an area where it's really easy to miss. And if we don't have that tag properly set, that's going to have a major impact in our code, right? Because we won't know that this object is an apple. So that's one of those little teeny inspector things that can cause a lot of trouble. Okay, now that we have our apple all created, we know that it's tagged as an apple. It has gravity and mass. Let's make it a prefab. So I want to drag my apple from my hierarchy window and drop it on my project window. And now I see that I have my apple prefab. Now, to make sure that your Apple prefab is working right, let's delete our Apple over here from the hierarchy. Delete. And then we could drag an Apple back on there and see our Apple. So I'm going to delete it again because we don't want it to necessarily be on the scene when it starts. Okay, so that looks great. Let's save again. So my scene is looking empty, but I know it's not. I know I have my, if I zoom in, I have my apple tree somewhere, and I have my Apple prefab that I can use in my code. So now let's create our basket. The basket is going to be the object that we use at the bottom of the screen to catch our apples. So our theory is here again, our apple tree is going to be going from side to side, dropping apples. We're going to be controlling a basket down at the bottom, trying to catch the apples. So that's how we're going to be playing. So let's create our basket. So we're getting all of our beautiful, awesome art objects created here first. So let's do it. Game object. This time we want to create a 3D object cube. But this isn't actually going to be our whole basket. It'll be interesting how we create it. You'll see. Now on our cube, let's set our transform properties. Again, 0, 0, 0, 0, 0, 0, and then down on our scale, we're going to make this more one side of the basket. So we want it to be 4, 1, and 4. So it's kind of a flat, wide rectangle that we can use. Now let's create a new material for our basket. So I want to create a material. We'll call it MAT_basket. And let's set up a color for it. And they say they want it to be kind of a light, desaturated yellow. Come on, color wheel. There it is. Oh no, there's my basket. Now it looks too much like my other stuff. I'll go a little yellower. A little too desaturated. So you decide how you want it. I think that's the ugliest color ever. And let's put that on our basket. Go ahead and rename your cube to basket. So my ugly basket is coming together here. I'm okay though, because my tree is looking good. So for my ugly basket, I need to add a rigid body. I don't want my basket to fall down off the scene though, so I'm going to uncheck use gravity. But I am going to check the is kinematic. They explain it in here. Let's search and see. It's really a good question. Don't affect it. So it's kind of like it's there and can catch the apples, but it doesn't cause like bouncing.
Well, it's like the different. It's like shooting a bullet. Like it's the type of physics it uses. So like when you shoot a bullet, it has like kinetic force behind it. And so like it adds like certain attributes depending on how fast it's being shot, and if it hits an object, you'll apply that force to it.
That makes sense. I think the bullet analogy is the best. So you're saying that, you know, depending on what's going on, it's going to be affected by gravity and other forces. Particle kinematics is the study of a trajectory of a particle. So I'll let you do some looking up of that. But that's definitely one of the checkboxes here that would cause you a huge amount of coding effort if you were creating your own game engine, right? So that's one of those areas where having somebody else do it is really, really helpful. So try some different things. Try turning it off and on and seeing how things get impacted. Now, with our basket here, though, we're ready to make it into a prefab. So I'm going to drag my basket over. Bless you. Bless you. Bless you. Bless you. And then I'm going to delete it from my hierarchy window because I just need that prefab. And then let's save our scene. And we should have all of our art objects created here, our art components. How's everybody's looking? Sure. Okay, we have that Zoom session going if you guys want to use that computer. These items are so small. It's like impossible to see if you're not looking at the Zoom session. Okay, the last thing we need to do before we start coding is setting up our camera. So our camera, let's take a look at it right now. We want a camera that kind of shows enough of our play area that it's meaningful for the tree to be going back and forth, right? Because right now, if we look at it, let's see, I'm going to click on my tree. I'm going to set it back to a Y position of 0 so I can see it better. And I'm going to play my game here without changing anything. So right now I have some view. I could see it going back and forth. That's not too bad. But let's try our different camera angles here and see what we can do. I'm going to click on my camera. And right now we have a perspective camera. How can you tell? Let's take a look at some of your camera properties. Do you see anything that tells you that?
Projection, perspective.
Perfect. So we see kind of that way. That's kind of like our eyes see. We see a perspective of things, like things that are further away from us look smaller, right? That's perspective. Let's change it to orthographic. And they say with an orthographic camera, because we have kind of two-dimensional gameplay here, even though we have 3D objects, we're not going to have objects that are further away. It's sort of 2D that everything's just going to be in the same spot. We can use the orthographic camera that gives us more two-dimensional view. And they say, I don't know if this is true, but I've read that says orthographic camera is like a bird sees. I don't know, and that's why they run into Windows. I don't know if that's true. But anyways, let's change it and let's run this again. You may not really see much difference with this game. It might be something that you have, oh, yep, I do see a difference. My tree is kind of right up in front of me here, right front and center. So let's change some other settings on that camera. Just changing it to orthographic did change a little bit. But we want to make sure it's set properly for what we're doing here. So our camera settings, they want us to use orthographic, and they want our position to be 0, 0, -10. They want our rotation to be 0, 0, 0, and our scale to be 1, 1, 1. It just moves it back down from where we had kind of moved it earlier. There isn't really anything else that we need to, oh yeah, our size. If you notice, our tree kind of got really big right up front and center. Let's change our size to 16. I'm checking our other settings here to make sure that there's no other ones they want us to change. That looks good.
I don't have size.
Say, change it to orthographic.
Oh, right.
And remember with the orthographic then, everything is the same size. So now we have that size parameter. So we don't need that if we're looking at a perspective camera, because things will be sized depending on the perspective, right? How close they are or how far they are. Okay, good. I think that's good. Now let's look at, there's a pop-up menu. Let's find it. At the top of your game pane, so I'm going to click on my game tab and see where it says free aspect. This is our aspect ratio pop-up menu. And of course, when we're working with aspect ratios, we're going to be dependent upon what kind of environment we're planning on this game being deployed in. We know that with Unity, we could generate this game to run on an iPhone or an Android or all these different platforms, but we might have to change our aspect ratio, right? Because depending on where we're gonna run it, might not look very good with the same aspect ratio. So we're gonna choose 16:9 right now, and that's the standard format for widescreen TVs and computer monitors. So it should look nice if we play the game full screen. So I'm gonna click on my 16:9, and they say also, uncheck the low resolution aspect ratios if you're on a Mac. So we're not, we'll leave it checked. You guys could try it without it if you wanted to and see if it slows down your gameplay a lot, so it's having to do more rendering. Oh, okay, so it's a mute point. So let's run it again and see if we see any differences. I want to maximize on play because I just changed that aspect ratio setting. So I'd like to see how it looks full screen. I'll run it. Should see my, yeah, almost fullish. Fullish. So not too bad, not looking too bad. I like it.
There is no round.
So we need to do some code. Before we take a code break, let's take a break. Since we're here for so long today, I'm going to save. But let's take about 5 minutes. We need to go to the restroom, do stuff like that. Come back at about 9:18.
While we're on break, can you put the basket so I can finish it?
Sure.
We got the Zoom session up, but we had moved on.
All righty, there you go. See if that shows you everything you need.
Thank you. Here we are. Wait, so for the materials,
Mm-hmm.
you have an MET basket, Apple MET basket. Why do you have MET? Short for material. Should you make it? How did you get the mesh filter on the basket to say cube?
Say what?
The mesh filter you have the cube mesh filter has the cube up there. Right. Click on the Zoom session right I did it on my oh, there it is. Okay. So yeah, I'm trying to organize it from some stuff elsewhere. So I got like everything else scripts, keep them prefab,
Not.
like, do a lot of stuff with that rather than do before, so I agree with this.
Why you be like this?
I have to say, one not so.
You be so.
Technical artwork is really interesting. A lot of programmers do that. Have you heard of a super FX? Nintendo had a super FX chip.
Oh.
It allowed for early
Oh.
3D modeling to show.
Oh, you'll love some of this stuff. Like a terrible pickup. With the kid, I was worried about him. I had that surgery, and I was like, man, he's got it worse than I did. I think get really something.
I was doing I've done some research on how the super FX chip works and stuff. I'm honestly impressed that they were able to get that to fit on the hard back. It was having early polygons, early kind of 3D. That was they used what was called a silicon graphics. So it starts out with 0 to 2, that's just what I was back then. Just having an engine that powerful actually got really hot. But you know, there was enough work. So then just really sensitive to 0. So first, like this back as it shows. My dad, he may have not made things, but he yeah, the only problem though is as soon as I get this finished, as soon as we get this finished, I won't be able to put, I won't be able to look at it on my computer. I have a newer version. I still get the newer version.
Yeah, actually, if it goes underneath that sheet. Well, it's got to be a way. I know, but I mean, it's underneath that. It's if more is greater than player press.
This is
the sensory. And then yeah, so you change your instead of high score.
You don't need to worry about that.
Okay, and now in the actual
I'm
body of that.
assuming they consider what being told from emails from her, so watch for emails from her. Because she's the one who'll tell you about stage,
Dot, set and
where to
and then
we'll all be going to the same place.
the quotation again, the same place. And then after the quotation, you'll put score.
So you touched them.
I've done it both ways. So that means we'll correctly create.
There has to be a visual.
Like this is my folder. Like all these projects are here. You go here and like Java files and stuff. But when you go into here, you have
that
like
should
different
work.
content. And like I said,
It's missing stuff.
so everything I do, and then actually you can use GetCrackin for everything they're correct. And it's the same thing.
But it's still missing stuff. So look at, go to that folder where all of your stuff is. And NetBeans is really picky about this. So it's let me go to one if I can find one and show you.
Is it because of that without giving more?
No, it's because where did I put that? I guess I put that on my document on the local. It is because you have to push the entire project folder. So here's one, listing 14.1. See how it's got to have this NB project folder? Because that tells NetBeans it's a NetBeans project. If NetBeans doesn't see that NB project folder, it doesn't open the it doesn't display the project as a project. So whenever I go to NetBeans,
Oh, yeah.
and fiddle with it, because you'll see that it can do different things. When we created that project, by default, it only wanted to upload just my .java file to NetBeans. So I had to, it's so slow because Unity's running, it's like, I can't do it.
I'm really surprised that they didn't use the feature.
Oh my God. Whenever they updated Markley's room a couple years ago, they didn't even give her a computer. They gave her this, I don't even know what it was because she was busy having a meltdown, so I didn't get to hear a whole lot about it. But they gave her like a display station, since all instructors need is to be able to display PowerPoints and stuff. So they don't understand what we do.
But they're going to give you extra monitors, yeah, board, and then they're going to let you use this little tiny.
Stupid piece of crap. Well, nobody, and you know, nobody ever asked me what I wanted as a computer, because I would have said, no, I don't want this little teeny thing. I want a desktop that has a decent video card in it, because we do video game programming. Come on, give me a break. But I was not asked. So since our department head wasn't concerned about it, it's what we get. So whenever we have someone who's not a technology person, making me crazy, give me 4K monitors with 2 gig video cards. Oh my God. Get me started on these dumb monitors. So I have to check in at that top level. So like I'll come right here on this project level,
Yeah.
and do get, add, or commit to make sure the whole thing gets pushed. So even if you're creating it in your Git folder, you still have to make sure you go up to that top project level to do your commit, or it doesn't add all those other project files. So try it, yeah, and see.
Now commit, like that is just like doing it on your local machine, right?
Right.
Okay.
So they're all ready, they're packaged, ready to go, and then you're going to push them up there. Yes, sir.
Did you, on your basket, did you make a high score? No. That's last
Just so
name.
you have 3. Just make it 3. Yeah, they won't know.
So is your high score? I don't know why it's wrong. I'm obsessed. I never.
obviously you have your high score straight. You also have to go into, I think it was the apple where it's destroying the apples.
You're right.
The high school. And check.
You're right. Because there is where it destroys the fast.
Yeah. Now you're looking for the one where it destroys the apples. I forget which one.
Oh, yeah. Well, we need the tree.
So I should probably, that would be the.
Or maybe it's in the basket. Check the basket. Yeah, I guess it'd be a basket.
No, you're destroying the basket and the applicant code. And the applicant code.
Way out.
Slow down. Should be, that's a basket, you get destroyed right there.
And then that restores the
Yeah.
Is it missing
I want to say it's actually where it's destroying the apples. So, no, it's in the basket.
Okay, so that's great.
Basket.
we're in right in the apple right now?
Destroy the apple. See, yeah, I think that's let me pull up my
Okay.
Now, do you know how to for professionally, as in we be initiated by contact with it's just not right. Did you clone or are you trying to initiate the books? It's not in Apple.
Well, Apple Picker does destroy. It iterates through it iterates where with the apple. With Apple Picker, it destroys the apples after everything after all the passes.
Let's see. In the basket, do you have this as score greater than high score, dot score equals score?
Yes.
You do. Okay. That's all right. It's not in the basket. It's in high score. Do you have this one? Player preps dot set in Apple Picker high score score. Now in high score. You do.
Did you add your high school script to the game?
Yes, it's attached to. So you're gonna get Apple Picker. I don't see Apple Picker.
I got stuff there. I don't know if it's not there yet.
We have that in high school.
Yeah.
Okay. That's
So you staged all yours. You sure you touched the script?
yes.
And you make your
I just have
little message.
you need to use it. That's what your best decision is. To the apple tree. No, I don't know why. I remember that when I was watching her video, right? She specifically said you have to check for the push. That might have been what this one was. You track your high score.
Yeah, push successful. Your skill. You should be able to see the change. You're what?
Why do you already have one basket static? There's a USB pin right there and it's stock. Oh, you gotta go back to the properties for that. You're gonna survey of your data on your scripts. It's looking for as far as the assignment.
What did you make your high school? What did you create? What kind of? Oh, and that's why. So we created three text,
Yeah.
and that's what.
Oh,
And that's how you get the whole text.
So let's try this. Let me try this because I did it from the book is what I did.
Yeah, you have
follow
to.
the
Well,
videos.
you're not touching my book.
So that's what it is. Let
Yeah.
me go back.
Is ours is a text that has the,
Yeah.
calling the GUI tags. You can grab the text options.
Yeah.
Nothing yet.
But you still miss my first thing. So
It's just hiding from you.
I still strong.
Oh, and first of all, it's sale.
Oh, okay. Yeah, that's exactly why.
That's what we're gonna do.
So that's weird.
Let's do it.
Yeah, so I followed the book, which is why I did.
Yeah.
Let's get this thing done, man. We might be able to get it all done today. Wouldn't that be cool? Okay, so whenever we're looking at our apples, we want to think about what's going to happen. So whenever we have a frame change, a new frame displayed, we are going to be having some action. Our tree is going to be moving either left or right, and we're going to be deciding, should it change directions? Did it hit the side? If it hit a side, then we want to change directions and move the other direction. Okay, so if it didn't hit a side, we'll just keep going. Next, is it time to drop an apple? If it is, we're going to drop an apple. If it's not, we won't. But that's basically what's going to happen every frame. So we'll be making these decisions. Should we change directions? Should we drop an apple? So this is what our code is going to be taking care of for us. So our actions that we need to code are to make sure that we're moving a certain speed so that we know how much movement has occurred each frame. Change directions when we hit the edge. So that means we're going to have some decision-making logic to figure out if we hit an edge. Change directions based on random chance. So once in a while, we want our tree to just randomly switch to the other direction, and we're going to keep dropping an apple every second. So we should be able to get this all set. Now, in the book, they actually include the code that we need. So we should be able to get this going fairly quickly. We're going to type all the code, though. We won't be doing any sort of copying and pasting. Just want to make sure that we're getting some practice. So some of the code for our new to C# people will be quite interesting. So just let anybody know if you have some questions about it. The first one we want to work on is our apple tree. So down in our project pane, find your apple tree script and double click on it. Oh, did I? Doesn't matter. I'll get that other one too. Apple tree. And for all that's right and good, we can have them all open in Visual Studio all at once, right? Because we're going to be working on all of them. But do I have the right one? Apple tree, I do. Now, right here, this apple tree name, I'm hanging a little bit, must match the name of our script. So the class name and the script physical name have to be the same. And that's where if you copied and pasted, you might have to change that if it wasn't the same. Now we need some class level variables. So our class level variables are going to be the variables that show up in inspector. So people used to always call these inspector variables. And probably if you were watching some YouTube videos, you'd hear somebody use that term, inspector variables. So the first one is going to be, where is our prefab for instantiating apples? All of these variables up here that are class level at the top of our class are going to be labeled public, and that's what makes them show up in the inspector. Now our apple is a type of game object, so that's what our data type will be. So this is going to be a public variable. that's going to be a game object data type, and we're going to call it our Apple Prefab. BB, find the B. Next, we're going to keep track of the speed at which the apple tree moves. We're making this an inspector variable, so we could actually change it on the fly as our game is running if we wanted to. It's a number, and although it's going to not necessarily have decimal places to start, it could, so we'll make it a data type float, which means it's a number with a decimal place. We're going to name this variable speed, and we're going to start out with a value of 1, and the F just says it's a 1 float, so that it can be initialized properly. Now next, we're going to have the distance where the apple tree turns. So this will be another float type variable, and we're going to name it a little bit long, left and right edge, and we're going to say it's 10. So 10 units, if you remember, because we're always relative to what kind of device we're displaying on and all of those kinds of things. Now after the distance where our apple tree floats, we're going to have chance that the apple tree will change directions. And we'll see how this one's used. It's really interesting. Chance to change directions, long variable name. And this one is going to start out at a value of 0.1 and still be a float. So this says, how often will it be changing? Now we're seeing a lot of light bulbs in Visual Studio and things like that. Don't worry about them too much because it's not had the Unity extensions installed, so it might not be quite as smart about Unity as we wish it was. Our last public variable for this script is going to be the rate at which apples will be instantiated. Seconds between apple drops. And that's going to be a value of 1 also. And so what's cool about us putting these out here as public variables or inspector variables, like I said, we can change them as the game is playing, so you can see what an impact they'll have on our logic as we change them. Now, as we look here, we don't really have anything going on, but we can set this up to our apple tree. So I'm going to save. I'll go ahead and do a save all in Visual Studio. I just had the one script that I changed, but I like to always do a save all. And I'll minimize Visual Studio. Now, when I'm in Unity, because my apple tree script was the last thing I clicked on, it's still selected. So notice that all that code we typed in now is showing up over here in the inspector for that script. We wouldn't want to update it over here, but we can see it, so we can kind of see what's going on. Now we want to associate our script with our apple tree. So let's click on our apple tree and drag our script and drop it on the apple tree or on the inspector window for the apple tree, and then we should see our apple tree script. Now this is why we didn't delete the apple tree from our hierarchy when we created the prefab, because we weren't quite done building our apple tree. It didn't have the script association with it. Now we can see all of these variables here that are ready to go. Okay. Now, if we tried to run, will it run? Not doing anything though, right? Can't see any changes. Not doing a thing, but at least we see all our variables, so we know it's all associated properly. Okay, so what they want to do then is let's move our apple tree around a little bit and kind of decide what your limit for your left and right movement is. So they clicked on the tree and kind of drug it around and made some changes and decided. And they decided that for the best look for them, they changed their position, y coordinate, to 12. And they changed their left and right edge value to 20. Now again, we're not going to really see much going on because we don't see anything happening yet. So let's make something happen. Whenever you're working with Unity, you can always go to the Unity reference. Let's look at your help window. And under help, you see about Unity. You know, that's going to tell you what version you're running and all that great stuff that the about screen always tells you. But if you go to the Unity manual, you can see the Unity manual on your own. Let's see what it looks like. Here's our user's manual. It's going to have all sorts of different things, different categories, different sections, tutorials. And then if you look at the scripting reference, that's going to take you straight to the reference for code. Oh, I used Internet Explorer, yep. Okay, leave it alone. But in our scripting API, you will be able to find every single command that you can use within Unity to know how that works. So those are available to you. Get to know them, look at them, see if you can figure out how things work. Mine's going to hang now. There it goes, finally. All right, so I want to add some code. I still have Visual Studio open, so I'm just going to click on it. And I want to put this code in my update method. So in my update method, I'm going to start out by setting a variable for the position of the tree. Now our tree, whenever we're looking at Unity, it has 3 properties, 3 values for its position, right? The X, Y, and Z coordinates. So if I'm going to save that position, I need a variable that can hold all 3 of those values. And there is a special data type called vector3, which will hold those 3 values, my X, Y, and Z positions. So I'm going to create a variable of vector3 data type, and I'm going to name it POS for position. Now I want to set that position equal to the transform position of our apple tree right now. So that's basically saving the current position at X, Y, and Z position. Now, because our position variable is a vector3 data type, it has multiple properties. The properties it has are its X property, its Y property, and its Z property. We're going to affect its X property because we want it to move across the screen, right? And we always know that across axis is our X axis. So we want to change the value of X. So what do we want to do to that? Well, let's do a fancy formula here. We could just put, 5 and it would jump to that spot. That wouldn't be very good. So let's say we want to change our X value and we want to set it based on our current speed. And then we're going to multiply our current speed by a value called time.delta time. And of course, that has some special meaning. Find it here if I can get it to it. To it. So delta time tells us the number of seconds that have passed since the last frame. Since delta time is usually very small, like for a game running at 25 frames per second, time.delta time is 0.04, meaning that each frame takes 4/100ths of a second to display. And of course, if you had a super busy frame that had all sorts of things running around and 3D graphics and stuff, then it would take longer to display, and your delta time would be different because it's dependent upon this scene. How long does it take? So we can use that as a really good tool for changing positions. So it's just to change position a small amount, right? Based on how long it takes for each frame to display in our game. Now, once we've changed the value of the X in our position variable, our vector3 variable, we need to apply that variable to update our current position. So we want to take our transform position from what it is right now and change it to our POS variable. Because in our POS variable, we changed the position of X. So now this should happen every time there's a frame refresh, every time there's an update. So let's do a save all, and let's try our game. We should see some action now. So there it goes, it's moving. Now we don't have any code in right yet to tell it that it's hit the edge and make it reverse directions or anything like that. So right now it's just moving across the screen, and it will just keep going until it disappears off the edge. And it's fallen and it can't get up. So now it's gone. We can make our wall wherever we want. So we don't have to have anything there, but your players might like it. If you did, they might like to know where it was, but you don't have to tell them if you don't want to. So let's see, I want to change mine to not maximize because I want to run this, and I want to change my speed so we can affect that. So here it goes, and it was my speed variable. So what if I make my speed 100? Oh, that mattered, didn't it? So now I could change my speed. I got to start over again since my poor tree just disappears. But I could make my speed 50 and have a huge impact. So we can adjust those inspector variables while we're playing the game.
If you make it negative, will it go the other way?
Let's try it. See what it does. So I'm moving very slowly. Let's try -10. Good thought. Perfect. Okay, so cool. We can make it change. And it's really neat because that gives us the ability to immediately see how that variable impacts what we're doing. So that's why those inspector variables are so cool, because we can change them. So let's make our script do a little bit more. We had a lot going on in that one. That one was a big one. So I'm going to go back to Visual Studio to my script. So looking at my apple tree here, right under where we are, let's add a little bit more. So first, let's add a comment. Basic movement across the screen. That's what those 3 lines of code did, right? Or just our basic moving. Now, next we want to do some things for changing direction. So we're going to use some decision making, some if statements. And in C#, our condition has to always be within parentheses. So what do I want to check here? Well, I want to use our position variable, and I want to look at the X property. And first of all, I want to know, is this less than?
That's less than.
Our negative left and right edge? So remember, that's another variable that we set up, left and right edge. And we're going to use that little trick there of making it negative. Now, if that's true, what does that mean? Let's check. We're going to change our speed. Now, you guys are so good that you already kind of figured this out. If we're working with a positive value, we're moving right. So we can use a math function, mathf, and use its absolute value method to make our speed be an absolute value, which means not positive or negative, right? An absolute value is always with no sign. So basically, by taking that absolute value, we can move to the right. Now, we want to make an else down here. Else if the position of our x property is greater than the left and right edge not being negative, and I'm going to press enter and do my curly braces. If that's the case, then I want to set the speed equal to negative. And you guys could find a lot of different sample code for doing this. That's just the way the guy that wrote the book liked. So we'll say this one makes it move left.
Yeah, and typo right after that. Or correction, I don't know.
Do I?
Don't you need a semicolon after the else? Oh, wait, no.
I do not want a semicolon. If I put a semicolon, then I would be ending my if statement, and I would get improper results. It's a really good question because it's a really easy mistake to make. So we could, if we wanted to, put that else if on its own line. Let's do it that way because we have a lot of new programmers. And then we can see that we have the opening and closing curly braces for each half of it. So perfect. Let's try it. We should be able to save. And now we should see something do something different. Come on, do it. Oh, I have an error. Do you see my error down here at the bottom? It says all errors have to be fixed before you can enter play mode. Well, what is my error? I can look at the console.
Pretty sure you spelled right though.
Did I? And it'll show me my errors. He saw it. He says I spelled something wrong. Let's check this error. Notice that it's telling me, first of all, what time it is. That's super helpful. It says that it's in my assets/Apple tree. So I know it's in my Apple tree script, which makes sense because that's the only one I've changed, right? But I could have changed some others. It says it's on line 34. The name left and right edge does not exist in the current context. So I have a typo.
It's up when you declare the variable.
When I declared the variable, oh, thank you, sir. Left and, I switched my T and H. Doesn't it? Now let's save all. You can see if it will run. I kept clicking it and it wasn't. Now those errors, if you notice, are really, really small. So you're always looking for red down there at the bottom where it's complaining to you about something. Okay, so I'm going to make my speed just a little bit faster so that I can get there someday. And sure enough, I bounced when I hit the edge. Bounce. So I'm moving back and forth the way I want to. That looks good. And I could actually go a little farther. Oh, my left and right edge went back to 10. I'll go to 20 and see how that works. It is going a little further, a little closer. I could almost maybe even go to 25. But I can try these things using these inspector variables. And then I could change the default values in my script based on what I decide is the best position. So for me, 25 is actually pretty good. Goes all the way kind of edge to edge. So if I want to make that a permanent change, I'll change my script. Let's see, left and right edge. I'll make it be 25 instead of 10. And then that should be a little bit better of edge to edgeness. Now I'd like to add one more thing in our changing position, because we'd like to once in a while just randomly change position for no reason other than we got a random urge to. So let's go add more to that if statement. So right now our if statement says if our X position is less than a negative of our edge, meaning it's gotten over to this side, we want to switch it. If it's greater than this edge, we want to switch it, and we're going to add another else if. So for this one, we're going to say, what if we come up with a random value, and that random value is less than our chance to change direction variable, which again, we could mess with it and see if that has a good value that we like or if we want to change it. So if our random value that we get generated from the random number generator, which Unity is going to take care of for us, if that value is less than that change directions value, let's switch it. And all we have to do that is multiply our speed by -1. Fancy math tricks, right? So now if we save and run, we should see our apple tree changing directions randomly. Man, mine's changing directions randomly like crazy. What about yours? So maybe it's a little too low of a value. Let's do 0.2. Is that better? A little bit. Still kind of crazy. I might go up to like 0.6. See if that's better.
You want it to go lower. Go 0.0, like 0.00.
I hate those numbers. Okay, do what?
You want to go lower.
Low.
Yeah.
Less awesome. Less off 10.
Yeah, no, it just freaks out. I put mine at 0.045 when I made it, and it.
Did it work good?
Right. Don't need to look even, but.
Much better. It does change a lot. So what they say is, realize that this value, this chance to change directions, is not time-based. So if we had it set at 0.02, or 2% really, that would be a 2% chance exists that it would change directions on a really fast computer. That chance could happen 400 times per second. But on a really slow computer, it could happen as few as 30 times per second. So realize that one is really going to change depending on computer speed. So we could fix this. So let's fix it. Let's close all this. And let's go back to our Visual Studio script. And instead of having our changing direction code in the update, let's have our changing direction code in fixed update. In fixed update, which is called exactly 50 times per second, irregardless of the computer's frame rate and speed, will give us a more accurate value. So I'm going to go to the closing curly brace for my update method. All our new C# programmers, stay with us here. So here at the very end, we have 2 closing curly braces. We're going to put this new code between them. So I want my new code to go after the second to last closing curly brace. When I press enter and I get a blank line between the two, I'm going to add void fixed update. And that's going to mean run this code 50 times every second instead of when there is an update. So I want this little piece of code up here. So I'm going to select my opening and closing curly braces and my else if. And I'm going to cut those. And I'm going to paste them within this new fixed update method. And I'm going to get rid of that word else so that it just says if. So now I shouldn't have any errors. And instead of doing this random change every screen refresh, we'll just be doing it on a timed basis. So let's save that. Now I haven't changed the value of that variable, so it's still set at 0.1. I'm going to run now and see if it's a little bit better. Still a little flaky. I'm going to change it to the 0.02 that they recommend. That seems a little better. Okay, so with your compiler, make sure that all of the curly braces are in the right place. That's probably going to be what will get you guys. Do you see any problems there? Visual Studio is like, I'm not going to help you. You're on your own.
I think I.
It doesn't help you.
Okay. Now it says show compile error notification.
So look at the code that you have. Oh, thank you, Anthony. I thought we had it all fixed. Okay. And some of them, no matter, act like they don't care, and they don't
I guess I just have to, where is that? What is that? There we go. Thank you. Because it's not the writing center, it's its own little thing.
Guys, where do you go to get help with your resume?
So the career center, if you go to the Commons building, they have an office upstairs where like different where the big classroom is where they got your counselors there, your persons there.
Oh, up there by the VA?
Yeah.
Okay.
Cause I put my resume on the website and they send me back revisions.
Oh, cool.
I didn't ask.
So they'll look at it.
Yeah.
But they even have a book for you, you know, it's called like Getting a Job or something. And it like goes through there and like shows you how to build resumes. And then she will, I've only talked to one of them, but
Take those requirements with you though, because that makes it not a normal resume. Because you don't want them to, oops, sorry, thinking that you're just being a slacker with all that new stuff on you. Because you have to have those special requirements. Thank you, guys. I knew there was something somewhere. Let's make our, what'd you find?
He moved, and that moved left statement, he moved it down to you.
Oh, thank you, sir. All right, we're all found then. All right, getting everything done. Let's drop some apples so we have some action going on here before we leave today. All right, so in our program so far, we have our apple tree moving around back and forth, which is great, really good progress. But now we would like to have some apples falling from our tree as it moves back and forth. So right now, if we look at, if we look at our apple tree, if I select it in the hierarchy screen, and I'm looking at it in the inspector over here, we have this apple prefab variable that's not set. Well, before we leave this script, let's set that. What we would like for our apple tree to use as an apple is our apple prefab. So I'm going to drag that and drop it into that variable on the inspector, and that creates that connection. So now in our script code, if we refer to that apple prefab variable, it'll know we're talking about this apple prefab. Now we want to start dropping apples at the very beginning when our apple tree first starts up. So let's put some code in our apple tree start method. So go back to your apple tree script, the one we've been working on. And this time we're going to be adding some things into our start method. So find your start method towards the top. And what we're going to do in this is we're going to set up an invocation. So we want to be dropping apples every second. So we're going to use this invoke keyword to set up this invocation. And we're going to say what I would like you to do is invoke this drop apple method. Whoops. And then after the name of the method, I'm going to put a value for how often. So every 2 units, I want you to invoke my drop apple method. Now let's create our drop apple method. I'm going to put it right under this start method so that we can keep them together. So it's going to say the keyword void again, and this time drop apple. So if we just put this code for how to drop an apple up here in our start method, it would only happen once when our game started. We want it to happen every so often or at an interval. So we set up this invoke method to say every 2 seconds or whatever, I want to drop an apple. It's not 2 seconds. We'll look at what that means as far as invoke. So how do I drop an apple? Well, first of all, my apple is going to be a game object. So I'm going to call this game object that I'm going to create apple. That's a good name, right? And every time I want to create a new apple on the screen, I'm going to do so by instantiating fancy big word, which means creating an instance of, and I'm going to do the greater than, less than braces. And within the greater than, less than braces, I'm going to tell Unity what type of thing to instantiate. We want to instantiate a game object. Now, what do we want that game object to be? Our Apple prefab. Now that creates a new Apple for us. Let's go ahead and on our Apple, set up its position. So just like with our Apple tree, we were able to use the transform position to move it around on the screen. We can capture our Apple's transform position. And then invoke the drop apple to occur every time we hit a seconds between apple drop boundary. Now, in the past in Unity, they would have used this command called invoke repeating, and then they would have just been able to put it in the start method, and it would have just kept going forever. So this is a little different. Here we're saying invoke a drop apple and set up another one in 2 seconds. And when we run the drop apple, we're saying invoke the drop apple and set up another one. So we're just basically setting up the linkage to run it again every 2 seconds. Let's see what it does. I'm going to save it all and try running it. See if we get some apples dropping. There, oh, ah!
Mike kind of did something similar.
I like that. That's very cool. It's doing something weird, isn't it?
It's the mesh between the apples and the tree collide. Trying to boost both of them.
Yeah, the apple tree is colliding. What's it doing? So find that. So you got some code that's not the same as it needs to be. So check your start and your drop apple there.
Wasn't there something you did about that?
Nope. Just the start and the drop apple. So that gets it going. Now they say that you want to change your rigid body inspector for your apple tree to add the if kinematic and see if that keeps you from flying off the edge there. But you know it's not, right? Yeah.
Is it a layer issue?
When I install the thing that gives you color, things like that might be a good thing for you.
How do I do that?
Well, not right now, we're not going to, because everybody else is waiting. But we did that last time. So we'll do that. C-sharp, that might be right. Okay, sorry. Apple prefab is not exist. So we've got
Sorry.
That's all right. Okay, so we've got everything going. Apples are going crazy. I'm going to change that value. So let me try it because I just would like to get our apples all dropping. So they say click on your apple tree object and on your rigid body, check the is kinematic. Now let's see if it goes flying off the screen when it drops an apple.
Mine's still not dropping apples.
Check your inspector and make sure you dragged your apple prefab in and dropped it on that field. Now it says you still have issues with the apples. Get it? Okay, so we have a few things we have to fix. Next time, we'll set our physics layer so we can make everything not, we can actually go in and say, this object does collide with these kinds of objects, but not with these kinds of objects. So we can specify all that so they don't affect each other. So we'll do that next time. And we can make it work. Let's see where we are calendar-wise, though. On the what?
On the prototyping,
Uh-huh.
it says on the assignment that it was like for week 5, but it's due the 4th. Is it still being on the 4th?
I bet not. Let me double check. I thought I had all those due dates set, but I don't think that would be correct.
It's the worst thing to shake it off all over again.
How old is she?
Yep, next time. Next time, you guys got a lot to do. Let's make sure that's right, though. What do you think? Yeah, that's pretty fast, huh?
I mean,
211. Yeah, we want that to be, I want them to be good. I don't want them to be bad. So that date should be 2/15.
Okay.
So let's fix that.
You know the words.
Mhm. Your version of it.
And then what's the difference between the pitches?
Hang on, let me fix that.
Wait, can I use that other one?
The other one?
Yeah, my Space Invaders?
Sure, you bet. Okay, so you have two things that are due on the 15th. Your pitch, what do you think of as your pitch? I want you to think of your pitch as you're trying to get some money to fund your game, right? So that's your pitch, yeah. You want to fund my game? You want to give me millions of dollars to pay my development staff because I have such a great game? Because you're going to be showing a prototype, right? It's not going to be like full all of your levels. You might have a couple of levels. You might not have levels. You might just have like theories, depending on where you are. But that's your pitch. So when you look at the pitch assignment, your pitch is your presentation about your game. We have 5 to 7 minutes. So what does that mean? I don't want you up here taking 20 minutes saying that you can't get things to work. We have too many people. Nobody gets 20 minutes saying that their game won't work here in this room. What should you do to make sure you can present your game? You should record it. If you don't think it's going to work here, make sure you got a recording of it that you can show everybody. So we'd like to see your game quickly, right? Yes, sir? Yeah, I know. That's why we have to look at this stuff. If you need help, that might be something that you have to figure out because we've got to get this done.
So since I know that I developed that one and have a different version, I can record all of that stuff.
You could. Now, what about your game story? This is just as many points.
Your game story. Now, you guys don't have to worry about this because you're doing your presentation, so you don't have to worry about it. So your game story is going to be like storyboard stuff, like your behind the scenes documentation.
How much? Like, how much do you need with the good?
Oh, this one is separate, right?
Yes, this one is separate. So to me, it depends. Like some people that are real artsy might have this beautifully drawn storyboard. Other people might have like pictures of their characters, you know, just depending on kind of the person, because this is so dependent upon different people. But now your SWOT analysis is important. This is exactly from the game programming contest from Skills USA, by the way. So the SWOT analysis, strengths, weaknesses, opportunities, and threats. What about those guys who came up with that game? Have you seen that game where it's the school shooting game?
Oh, yeah.
Where they have the school completely and the character walks around and shoots students and stuff. They had some weaknesses, right? Some definite weaknesses in the design there. Yeah, some problems. That's what we're looking for.
That game was also a virus.
Was it?
Yeah, it actually mined Bitcoin, it turned out.
Oh, does it? So it's just doing all sorts of great things for
It
you.
removed it from Steam for that and also for its
For it being so awful. But yeah, so those kinds of things, opportunities, threats. Okay, and then you got yours at home. Are you taking yours home? Can you email me? Email me if it's in trouble. And we'll figure out what's going on with that. You too, you guys. Sorry, we just always run out of time. We have so much to do. Okay, finish this up. Next time we'll finish it up actually, and then the rest of our time will be for you guys to assign your projects and stuff for that.
So I didn't realize because I just followed it step by step. And part of my problem is I use the canvas text. I use like the canvas text object to remove that shit. So what I'm going to do is just wait for you to go over it in class. Change it to 3D Matrix script. Because I don't know why I'm so excited. Like, it's weird. I really want to be after all the 3D objects. I want to like change it. Now I have to, I guess the way to do it is now to do like a nice work and then like an actual sport component. For some reason, I thought I fixed it. It's where it's not communicating and then it shows up twice overlap. And still doesn't resolve.
It's just so weird how sometimes they confuse things because they're on the same platform. And we should excel it.
But that's the beauty of the project.
Yeah.
Is you just leave it
And
on it.
just try it, yeah.
So I just,
All right.
I say it all.
And
And
then-
then here and just tell it to be changed.
And then just-
See, this would be the initial.
Thank you for moving that.
Oh, thank you for pointing it out. That's what I
I'm
wanted.
like, I'm trying to do stuff from the backwards my council. So I'm like
I
trying
did
to,
not want it.
I'm like trying to meet up with the client and get all this stuff.
Oh, thank you. That's a good project.
So my, I'm doing a project for my church and they use this like, I thought it was just a database when I originally communicated with them. And it's like looking into it, it's a full blown. And the problem that I have is that it's like a closed ecosystem that you open on top of for your clients. It's like, they do have APIs, but they don't have one specifically built for the component that you want to access. But there is like this API Explorer tool, but I don't know if it's going to give access to those things because it's not a secret component. And all the stuff he's asking for services and are for in its web facing. So it shows to the library of the prospect for some basic services. We just have to because it's a very popular system and it's across all the people that they have going to it. It helps their different industries communicate with each other. They just want to be able to deal with everything. You bought this ecosystem. You want yourself. So I can talk to the video and get to that.
What happened?
So I just it's testing not open. Open. So I have to reach out to no, see what she says because open as much as I'm going to do stuff for them, like Those letters are spaced. Those letters are spaced.
Right.
So it's I don't know why they opened it. They was open it. It was this process of
Oh, and sometimes you have people that are trying to.
It changes the name of the file.
Do something that they're not being right up front to tell you about. And that's a hard
part of it is he says that he knows all he has to tell. This version of what he calls is
Nice.
which is okay. They're using your tools to do the job.
right.
But what I'm doing is I'm building an app and I'm going to build it up front and so that everything's done right. And you can always want to use the very words.
Okay.
And the problem you're going to have is in order to take care of my app, we're going to have to figure out what we're supposed to take how the services work. If you're going to have to pay Azure or AWS or something, you're going to have to pay to put it on the stores. When those APIs update, who are you going to try to reach out to?
Yeah.
Like,
You have
there's a lot of
everything
learning curve with it.
Whenever you have everything saved. sure.
Good day, Rich. Okay.
Yeah, good luck. Let me know how much I need to hear what
It'll be
come up with,
interesting.
'cause that's such a hard one. And I just wanted to show you in GetCrackin to do it, knit, and push whenever you're ready. And then you'll be able to get everything from home.
So say I'm at home, right?
Mhm.
So then I just
Yeah.
download this thing again
Uh-huh.
and link it with this
Uh-huh.
URL again, and then I can just download it and go and then
Mhm.
submit.
Yeah.
Push.
Yep, nice.
Okay.
And you never need to clone after that first time. So then when you
Yeah.
come back here next time, we'll just pull or fetch.
How
all
does
this
that-
stuff.
So, but
So
it's
everything's
your
cracking.
so you would,
Yeah.
but how do you click on it like this first? Like, so I want to click this one.
So let me try. I'm not
I don't know.
sure.
I've never used it.
I always mess up that part, so we're gonna try.
I'm actually, I have, I used it in the Barclays class. But, I will say, I'm still trying to get to know.
Well, and I had it all, I just don't have that part where, because I spent so much time making videos about how to set it up initially. I just suck at how to use it, like day in, day out. So let's all try to remind me next week, we wanna pull or fetch first. And then start working on our projects, because I always mess that part up.
So
And then push it at the end.
the only ones I've ever used is Azure and TFS. Would do.
Because like with TFS, you do that latest
Yeah,
version,
that's easy.
and that we need to do that same type of thing to make sure we're working with the version the way you left it from home, so that we have all your updates. And that's the part I'm
That's just
missing.
where the
Because I'm always just throw it.
it's just updated.
I keep doing it. So now you should just be able to and scroll down over here and see if there's.
So this is just, this is all follow stuff, by the way, push.
So again, you're going to
Take it from this one,
just push.
That's changing.
Now, I want to look up the web and GitHub and see what it's got. So here we go.
You can't have a destination.
You refresh it and let's make sure.
So I mean, that first app is gonna be a but
Now, where's the understand my question? So go here, GetCrackin. Yeah, that looks good. So maybe let's do the changes of this here. These are and my sure initial committed with Apple Picker. Cool.
I get it from home.
To get it from home, come here, grab that, and do that. And then, that's what I was telling them. You guys remind me next week because we need to fetch or pull before we start working on it again, and then go from there. I am terrible because in class I always just start up at that same place. I don't ever update them at home like you guys do, and I was like, well, why is yours not working? Uh-huh. Okay.
I haven't worked on it too much yet.
Let's take a look. Yeah, I need to make a video for you guys, and I was terrible Wednesday and just sat there watching dumb TV shows because I thought I already had a video that shows it, and I don't. I'm like, oh no, I have to make it.
So, where is this?
Okay.
So, I guess first thing, we'll have to write content to us.
Yes. Yes. Yes, that's very good. So I'm gonna go make a video today, and I'll post it, and I'll show you how to convert those to numbers and how to make sure they're valid.
Convert in 62.
To in 64.
In 64.
But I'll show you how to
I've
do
always done 32.
in 32. 64 will take you 2 more.
Yeah.
So 32 would probably be better. I guess we can't start using 64-bit stuff.
For game dev, do they prefer you do conversions like that, or do they prefer you do projects?
Just conversions are fine, I think.
Okay.
So let me do this with mine. So we did few changes. Stage all changes.
Commit message. Gotta give a summary.
I have this core project out here on GitHub, like I don't know how many times. And I do it differently every single time, I swear. That's the hard part. Whoa, just let me do it one way. No.
What's the way to get the different colored?
Oh, go to in Visual Studio.
It's that
Tools,
Tools.
extensions and updates.
That's what I'm looking for.
And then on extension updates, click online, and then you can search for it. So you can search for colorize, curly braces, or anything, and it'll find it. You can
Was
search
it
for
ReSharper?
VS4 if you can remember the name of it.
We use
I was like, I
ReSharper
remember
here.
beginning with the B, and I was like, oh, what's it?
ReSharper adds additional capabilities, but it's that VS4 that's
one thing
color
I
coding
noticed
the curly braces.
When you were coding it this time,
Mhm.
it doesn't recognize vector 3
No,
or transform in position. But
Right.
mine at home
does
does.
because you installed the Unity extensions.
Okay, so
For
why
Visual
don't
Studio.
we have that?
Oh my God, that's a really good question. That's a really good question. I think I'll send you over to those help desk
Like, hey,
fellows.
I've been teaching this class for so and so years now. Why
Oh,
don't
let's
we have
see.
it?
It's because at this point they got it installed. And it's not a 2-year-old version. My goodness, last year we were working with a version that was over 18 months old. And with Unity, that's really old. You know what I mean? These guys over here are just like, to them, that's not that old because they'll wait to install a new version of Windows for 4 years.
10 years.
But I'm like, you guys, that's just so ancient. It's like archaic for us. So
Now it's so many new tools to make life easier for just quality of life on it, and then missing out on all the new features and stuff if you're wanting to develop and add stuff.
and I feel bad for them because I totally understand our software is so complicated. And if they don't have everything exactly the same, then they have people over there complaining about something that's different, and they go to spend all this time to figure it out and come to find out it's just one computer that somebody's messed up that isn't the same.
I
They're
don't
like,
know why we can't create sandboxes in here for us to install things on.
I don't either.
That's
It's craziness. Well, like I said before, we should be able to each have our own virtual machine. We shouldn't have to mess with it, but you have to, that's a problem with Windows, that you have to make people admins to run virtual machines, and that just wipes out the whole.
I remember a few years ago, back when I first came here and I had Samuelson,
We couldn't even use a flash drive.
That one semester they did that
Yes.
to
We
everybody.
couldn't use a flash drive. It would block it. And you're like, what now? How do I get home?
Poor Samuelson, because that's how he did everything,
Yeah.
and then you guys are like dead in the water. Poor guy. I know, and I was always so impressed with how he did that, and I was so glad I did it. And I did it this time too for the beginning of the Visual Studio stuff.
I like to have just for multiple copies. So I always
Yeah, I
have
like
a
that
flash drive
too.
version, and I usually have
And I'm the opposite. I was